4.4, which is solving linear systems again, but this time it's going to be in 3 variables. So the last 2 sections, we were solving systems, but we were solving systems where there were just 2 equations, and the only variables in those 2 equations were x and y, which we're very familiar with, right? If we graphed something, we're very familiar with graphing something where this is the x-axis, this is the y-axis, and if I have a point on this graph that's at 2, 3, let's say, I'd go over 2 on the x, and I'd go up 3 on the y, and my point right there would be 2, 3. But now we're working in a system with 3 variables, which is solved similarly to a system with 2 variables with a few extra steps, a couple extra steps at the beginning and then a couple at the end. But our solution now is, instead of an ordered pair, which is what this is, it's going to be an ordered triple, a point in 3-dimensional space, x, y, and now z. So to kind of imagine this, what I'd like you to do is pick something in the room. Okay, pick something that you can look at in the room, maybe something that's on the wall. So what I'm looking at right here, okay, I'm looking this way, and I can see my door to my classroom. Okay, the door to my classroom. Let me draw just a picture of what that kind of looks like. So here's my wall, and I've got my door right here, like that. I want you to pick something in your room as well. And when I'm looking directly at the door, everything that's running this way is my x. So the bottom and the top of my door frame, they would travel left and right. Those would be my x values. And the door frame itself going this way, I could call my y. But then now, and what I can't draw here because this is a 2-dimensional surface, but you're seeing your actual world in 3-dimensional space, is the depth from you to whatever you're looking at. So for me, it's from me to the door. That depth is now what's going to be your z. Okay, so we're used to seeing something like this, and now what we're doing is we're adding a depth to it. And so if you could imagine in front of you, you've got 3 lines, maybe 3 lines going in whatever directions, but they intersect at exactly 1 point. Well, that 1 point of intersection is what we're solving for. We're saying in this system, okay, this first example we've got here, in this system we've got 3 lines in 3-dimensional space, and they're all intersecting at exactly 1 point. The solution that we're looking for is the ordered triple, in which x equals this, y equals this, z equals this. That is that exact 1 point in which these 3 lines intersect. What I'd like you to do is, if you are ready to go down to this example, I would like to scroll down and give ourselves a little bit more room, because we're going to need it to work on this problem. Let me know when you're ready to do that by typing ready or done in chat, please. Awesome. Thank you. Okay, it looks like most people. So I'm going to go ahead and scroll down right here. Now, I want to preface, before we start, I want to preface that these problems take a lot of time to solve. Okay, they're a little bit time intensive, and not only that, they can get confusing, and there's lots of little tiny steps where we can make mistakes. So you have to be very diligent about keeping track of your work, which is why we're going to be using labels here for our equations. I want you to make sure that you're keeping track of negatives, so that way you don't have a little negative throw off your answer by a whole bunch at the very end. And also keep in mind that if at any point during these problems you're feeling confused or even I don't know, feeling confused or kind of just tense about these problems, that's okay. Okay? Feeling confused isn't something where you have to say, I don't get it, I'm going to give up. It's just a moment where you're saying, I'm being challenged by this, and being challenged by this means that I'm going to be learning. Okay? So instead of thinking of it as, I'm confused, I don't get it, I'm going to give up, think of it as, I am being challenged by this. I need to step up to that challenge and overcome whatever it is I'm working on. Now, that said, I have three equations here. Okay, I've got equation A, I've got equation B, and I've got equation C. And you'll notice that they not only have X and Y, I've also added Z's here. But we're going to approach this problem in kind of three phases, if you will. Phase one is going to be eliminating one of the variables so that I'm down to just two equations, two variables, which is what we have been solving the last couple sections. Okay, then phase two of this problem is going to be basically solving for one of the variables like we have been doing because we're going to be down to two variables left. And then phase three is just plugging everything in to find what the other variables are. Okay, so let's start. Phase one, we're going to eliminate one of the variables. And how I'm going to do that is not by eliminating a variable in all three equations. I just need a combination of two of the equations, and then I'm going to eliminate one of the variables from those two. Just to make things easy, I start out and I see that I've got 2x here and 2x here. Okay, if I use equation A and equation C as my combination of two equations, I don't need to do any work there because they already match, 2x, 2x. So over to the left, I'm going to write down that I'm going to start with A and I'm going to start with C. And I don't have to do any multiplication there. Exactly as they are, this is 2x plus y plus z equals 3. And C is 2x plus 2y minus z equals 6. And I've decided to eliminate the x's, 2x, 2x. Since they're the same sign, they're both positive, that means I can subtract. So I'm going to go ahead and subtract these equations, subtracting C from A. The x's will get eliminated. 2x minus 2x goes to 0. Y minus 2y is going to be negative 1y, so just negative y. Z minus negative z is going to make plus 2z, because I'm subtracting a negative. And this is equal to 3 minus 6 is negative 3. Now, what I've done here is I've started with two equations, A and C. I've subtracted one from the other, and I've created a brand new equation. This is important to note that there is no x in this equation. So I went from three variables to two variables. And as this is a new equation, I'm going to give it a new label. A, B, C, let's call it D. The next thing we're going to do is pick a different combination of equations. So I've already used A and C. Okay, I've already used A and C. I can't use A and C again, but I can do A and B or B and C. Okay, I can do A and B or B and C, and I'm still going to eliminate the X again. Now, if I just keep things simple and I say, let's do A and B, then I can't just add or subtract these to get rid of the x right away because this is 2 and this is 3. So I've got to do that clever multiplication in order to manipulate the equations in a way where the x's are going to kind of match up, where the coefficients on the x's are going to match up. The simplest way to do that is multiply equation A by the coefficient in front of x in equation B, and multiply equation B by the coefficient on x in equation A. Or in other words, 3A and 2B. So this means to multiply everything in A by 3. That's going to be 6x plus 3y plus 3z equals 9. And 2 times b means everything in b times 2, so that's 6x minus 4y minus 6z equals 34. Now the point of this was so that now I've got 6x and 6x, I can subtract, and when I subtract, the x will cancel. It'll be eliminated. What's left is going to be an equation down here with just y's and z's. So 3 minus negative 4 is going to be 7y. 3z minus negative 6z is going to be 9z. And 9 minus 34, well, that's going to be negative 25. I have created a brand new equation. I'm going to give it a brand new label. I've got A, B, C, D, E. That's phase one. Phase one was getting rid of one of the variables by using different combinations of your original equations so that you're left with a new equation D and a new equation E such that one of those variables, in this case x, is eliminated in both. Now, let's take D and E and move over to phase two, which I'm going to put in the middle here. Phase two is I'm going to take these two equations. D is negative y plus 2z equals negative 3, and E is 7y plus 9z equals negative 25. And just like I've done for all of the last section, I'm going to solve for one of the variables here by eliminating another variable, either y or z. Now, in the last section, you had x and y, right? Those were your two variables. Here we've got y and z, but these are just letters. These are just variables to us, okay? So it's fine that it isn't x and y and it's y and z now. That's fine. I'm still going to treat it the same way, treat z as if it were a variable x. What I would do is pick a variable to eliminate. I'm really happy that I see a single y, or negative 1y, because that means I can just multiply equation D by 7 and get those two to match up. So that's what I'm going to do. I'm going to say 7D, and E I'm going to keep as it is. So 7D just means everything in D times 7. That would be negative 7y plus 14z equals negative 21. And E stays the same, so that'd be 7y plus 9z equals negative 25. And since the y's are now exactly opposite, where one's negative and one's positive, I can go ahead and add these two equations together to eliminate the y. So 14z plus 9z, That's going to make 23z. And then negative 21 plus negative 25, that's going to make negative 46. Divide both sides by that 23. And you will find that z equals negative 2. Okay? So phase 1 was using different combinations of my original equations to get an equation D and an equation E, where in both of these two equations, I've eliminated the same variable, in this case, x. Phase 2 was exactly what we have been doing, where we take these two equations and we find a way to eliminate another variable. So I eliminated y so that I can solve, in this case, for z. Phase 3, which is the easiest part of it, okay, we've done all the hard work. Phase 3 is just plugging stuff in. What you're going to do is once you've solved z equals negative 2, you're going to take one step back. Okay? You're going to take one step back, and in my case, I'm going to physically take one step back to equations D and E. Equations D and E were those that I found without x. You're going to take z equals negative 2 and plug it into one of these. It doesn't matter which one. So I guess let's do the top one. So negative y plus 2z equals negative 3. I now know that z is negative 2. So this is negative y plus 2 times negative 2 equals negative 3. Negative y minus 4 equals negative 3. Add 4 to both sides. Negative y equals positive 1. And then divide both sides by negative 1. That's going to be y equals negative 1. So I got z equals negative 2. I took a step back in my problem, and I'm at the whiteboard, so I get to physically take a step back to D and E. I plug in z to one of these to find y. And then once I know what z and y are, I'm going to take another step back in my problem, or in my case, I get to physically take another step back to my original equations, and I'm going to pick one of them and plug in z and y. So if I take my original equation, let's say A, let's write it down here. Hopefully I've got enough room. A is 2x plus y, 2x plus y plus z equals 3. But I now know that z is negative 2 and y is negative 1. So this is 2x plus negative 1 plus negative 2 equals 3. 2x combined terms minus 3 equals 3. Add 3 to both sides. 2x equals 6. And then dividing both sides by 2, x equals 3. So this means that while I don't know in three-dimensional space, I have no idea what each of these equations, what each of these lines looks like graphically, I can tell you that the exact point in which the three are going to intersect is the ordered triple 3, negative 1, negative 2. Now that's a lot of work. And if you're thinking that's a lot of work, I agree with you, okay? How many people, let me know in chat, yes or no, how many people think that's a lot of work for one problem? Yeah? Yes? It is. Okay, so I'm not alone in this. But hopefully by now, yeah,
Look
go
at that
ahead.
page.
What was that?
Basically an entire page of
Yeah, it's basically an entire page, maybe slightly less than a page, but it's pretty close. Yeah. Now it is a lot of work, but hopefully you also have a kind of feeling that Mr. Seegers and I have kind of built you up to a point where through those other steps and through those other sections, all of this is at least 70 to 80%, hopefully, making sense. All the different steps that we took. And we're going to have more examples today. Okay, so this isn't the only one that we're going to do. Okay, I'm not just going to do one example and then kick you to the curb and say, do the rest yourself. We're going to do at least another one or two. All right. Before I get to the second one, any clarification things that I can help you answer? Any things that I did that you're like, I'm not exactly sure what you did right here, Mr. Ng. Could you explain that further? Okay, nothing yet. All right, in that case, we're going to erase this one. We're going to write one more up here, and we'll do that problem together. At least you did your problem in notebook paper. See, I did mine on the whiteboard, and you step away from it, and you're like, I feel so proud of all this work. But as it's on a whiteboard, I've got to now erase all of my hard work as if it meant nothing. You get to cherish it forever in your notebooks. Forever, right? All right, let's go ahead and write this one down now. Lily says, unless I burn the notebooks? Oh, no. However, if you burn the notebooks, matter never just disappears. So you've just taken that knowledge and you've just shared it with the world. You've burnt it, and the matter has now gone into the air, and you've shared it with the world. That's another way you can think of it. All right, so I've got three equations. I've got x minus 2y plus z equals 0. That's equation A. Equation B is 2x minus 2y plus 3z equals 7. And equation C, I've got 5x minus 3y minus 2z equals -7. So again, I do this problem in kind of three phases, right? The first phase of this problem is to use different combinations of my original equations here in such a way that I eliminate the same variable twice using two different combinations. And so to do that, I have to first select a variable to eliminate. Okay? Right away, two things are jumping out at me. I see that in equation A, I've got 1x and I've got 1z. Those two things are jumping right out at me because I love to see when I have just a single x or a single y or a single z, because then I can multiply that equation by whatever I needed to in order to match with another equation. So let's say, this time let's get rid of z. Okay, this time let's get rid of z. So what I'm going to do is I'm going to use the combination of a and b to eliminate z. And to do that, I would need to multiply equation a by 3 so that I've got 3z here and 3z there. All right, so to start things off, I'm going to have 3 times a. So 3 times equation a, and then equation b. So 3 times equation a would be 3x minus 6y plus 3z equals 0. And equation B is just exactly as I see it. I haven't done anything to it. So 2x minus 2y plus 3z equals 7. Since I am eliminating z, I've got positive 3, same sign, subtract. I'm going to subtract b from 3a, which will give me x. Negative 6 minus negative 2 is negative 4y. The z's are going to get eliminated there, and then 0 minus 7 equals negative 7. I have created a new equation. By subtracting b from 3 times a, I've created this equation. I have to also give it a label. So I've got a, b, c. Let's call this one d. Someone in chat asked, would it matter if I did A and C instead of A and B? No, because what I'm actually going to do next is A and C, because I need to do another combination. Okay, after I do this combination, I need to do another combination. So I'm going to do A and C as well, just like you did. And this time, I'm still eliminating Z. So this time, I'm going to multiply A by 2 so that this becomes 2Z, which will match exactly opposite of this negative 2Z. So this will be 2A, and I'm also going to use C. So 2 times equation A is going to be 2x minus 4y plus 2z equals 0. And C will be exactly the same, so 5x minus 3y minus 2z equals negative 7. This time, however, I see that this is positive and this is negative, so I'm going to be adding these two equations together. (7x) negative 4 plus negative 3 is also going to make negative 7, so negative 7y. The z's are going to get eliminated, equals 0 plus negative 7 is negative 7. So this is equation E, right? Because I've made a new equation. I have to give it a new label, A, B, C, D, E. Now, for E, I also notice that all of my coefficients and my constant have a 7. 7x, negative 7y equals negative 7. So what I could do is I could simplify this and divide both sides by 7 to make this so my numbers are a lot smaller and easier to work with. I think I actually like doing that. So I'm going to divide both sides by 7 here. Okay, this is kind of a rare occurrence, doesn't always happen. But this would give me x minus y equals negative 1. And let's call that E. I like that better. So that's phase 1. Phase 1 is finding two equations from your original ones using different combinations and eliminating one of the variables. In this case, I eliminated z, so that I'm left with these two equations with the same two variables, x and y. And I'm going to take that and I'm going to move it over here, where I'm going to put d here. This is x minus 4y equals negative 7, and e is going to be x minus y equals negative 1. This is now phase 2. Phase 2 is solving for either x or y through the process of elimination, just like you did in the last section. And luckily, I see that this is a single positive x, and this is a single positive x. I don't need to do any multiplication, right? They already match. So I could just go ahead and subtract. So I've got x minus this x. Okay, negative 4y minus negative y. That's going to be negative 3y equals negative 7 minus negative 1. It's going to make negative 6. Divide both sides by negative 3. And I get y equals 2. Okay, that's phase 2. Phase 3 is just plugging stuff back in, going back one step each time. So I got y equals 2. I'm going to go back one step to equations d and e, and I'm going to plug in y equals 2 to one of them, doesn't matter which one, to find what x is. So if I do equation e, that would be x minus y equals negative 1, but now y is 2. So this is really saying x minus 2 equals negative 1. I add 2 to both sides. X equals positive 1. So I got y equals 2. I took a step back to my equations d and e. Those are the ones that I found. Plugged y equals 2 into one of them. Okay, I picked e, plugged in 2. I got x equals 1. And then now I take another step back in my problem. Now I went from solving one variable to equations d and e, take another step back to equations a, b, c. I pick one of those, and I get to plug in y equals 2 and x equals 1 now. So if I just picked equation A, let's go over here because I've got more room. Equation A is x minus 2y plus z equals 0. But I now know that x equals 1 and y equals 2. So this is really saying 1 minus 2 times 2 plus z equals 0. 1 minus 4 plus z equals 0. Negative 3 plus z equals 0. Add 3 to both sides. Z equals 3. So while I have no idea in this three-dimensional space that I'm working with, I have no idea what this line, or this line look like, I can tell you that they intersect at exactly the point 1, 2, 3. X equals 1, y equals 2, z equals 3. Questions? Let's see, I see, does it matter which variable you choose to eliminate? So the person that asked that, at the very beginning, no. You could choose to eliminate z and use different combinations to do so. You could choose to eliminate y, or you could choose to eliminate x. So if you saw that there was one x here and you went, oh, I'd rather do 2a and b to get rid of that x, and then do 5a and c to get rid of the x there, you could have done that. The beauty of this is that there are so many different ways that, so many different routes that you could take to solve this problem, and they all take you at the very end to the exact same solution. So I could choose to eliminate x, I could choose to eliminate y, I could choose to eliminate z right away. So that's already 3 choices there. And then based on what I choose, if I choose to eliminate x, I've now got another choice of which combinations of equations do I want to do. So those are even more choices within your first choice. So it branches out, and you've got lots of different paths, lots of different routes that you could take to solve this problem. What I've done is simply one of them, but we're all going to get to the exact same place. Okay. Other questions here. I see. Oh, I just saw it takes up half my page. So that one was less. Okay. That one was less work. Other questions? Okay. Let me know in chat right now. You can just send me a private message. Before we go to lunch here, what are your initial kind of feelings about this? 1 through 5, like 5 being I'm totally getting it, I'm following along perfectly, 3 being somewhere in the middle, 1 being I have no idea what we're doing right now. I'm expecting most people to be around 3-ish, give or take a little bit. Okay, so let's see where we're at, and then we'll have lunch and we'll come back from lunch and do at least one more. I'm seeing a bunch of 4s, see some 3s, see about halfway, so 3. Okay. I got a couple people that are at 5, couple people at 1. That's all right. All right, so once you've given me kind of your feedback of how you're feeling, go ahead and take off for lunch. It is 11:50, and we'll reconvene at 12:18, and we'll do another problem. Okay, so have a good lunch. I'll see you in a bit. All right, we are back from break, and we have one more example to do for this section. Go ahead and write this down. I've got 3 equations. Equation A is 3x minus 2y plus 7z equals 13. Equation B is x plus 8y minus 6z equals negative 47. And equation C is 7x minus 9y minus 9z equals negative 3. So again, what I'm going to do here is I'm going to solve for x, y, and z using a process of elimination really in 3 phases. That first phase is using different combinations of these original ABC equations to eliminate one of the variables. And once I've done that, I can move into phase 2, where I've got 2 equations, 2 variables. You've pretty much done a whole bunch of problems like this from previous sections already. So you're going to find out what, maybe you find out what z is, okay, after eliminating x and y. And then once you have one of your variables solved, phase 3 is just going back one step each time and plugging those values in and finding what the remaining variables are. Okay, so phase 1, I need to pick an equation, 2 equations, and I need to pick a variable to eliminate. Now, what I really like right off the bat is I see that this x is a lone x, just a single x. Okay, and I like that because that tells me I can use that and multiply that equation B by whatever I need to in order to match the coefficients of x in the other equations. So what I'm going to do is I'm going to use equations A and B, only I'm going to multiply equation B by 3 to match this 3. Right? So I'm going to start by over here, A is exactly as it is, and then I'm going to do 3B. All right, so A is exactly as it is, 3x minus 2y plus 7z equals 13. And now I'm going to multiply everything in B by 3. So this is going to be 3x. Okay, 8 times 3 is going to be 24, so plus 24y. Minus 6 times 3 is 18, so minus 18z. Then negative 47 times 3, that's going to give me negative 141. All right, I'm eliminating the x. I've got positive 3x, same sign, subtract. So I'm going to subtract these two equations, x will get eliminated. Negative 2 minus 24, that's going to make negative 26y. 7 minus negative 18, that's going to make positive 25z. And then 13 minus negative 141 is 154. I've created a new equation. I've got equations A, B, and C, so I'm going to label this equation D. All right. The next part is to use a different combination. So I can't use A and B again to eliminate x. So this time I'm going to use B and C. Again, because this is a single x, I can multiply this by whatever I need to. In this case, 7, so that it matches up with this 7. So this is going to be a combination of 7b, and then C is as it is. All right, so 7 times everything in equation B. That's going to be 7x plus 56y. Okay, minus 6 times 7, that's going to be 42. So minus 42z. And negative 47 times 7 is going to be negative 329. All right. Now C is exactly as it is. So 7x, just copy and paste. 7x minus 9y minus 9z equals negative 3. Now I know we've got some bigger numbers here, but that's okay. I'm just going to keep going, see if when I get my first answer, if it makes sense or not. All right, so I've got 7x, same sign, subtract these two. X is going to eliminate, good. 56 minus negative 9, that's going to be 65y. Negative 42 minus negative 9 is going to make negative 33z. And negative 329 minus negative 3, that's going to be negative 326. I've created a new equation. I've got labels A, B, C, D. This one I'm going to call E. And now that I've got equations D and E, I'm going to go over to the middle, and I'm going to start phase 2. I'm going to write these two equations down as they are. Equation D is negative 26y plus 25z equals 154. And equation E is 65y minus 33z equals negative 326. I have to get either the coefficients on y or z to match, and it's not going to be pretty. The easiest way is just to multiply one equation by the coefficient in the other equation. I guess let's get rid of y. So that's going to be 65d and 26e. Ugh. All right, let's see what this gives me. 65d and 26e. I'm going to use a calculator here. Negative 26 times 65. That's going to be negative 1,690. So negative 1,690y plus 25 times 65 is 1,625. Z equals 154 times 65 is 10,010. All right, now everything in E multiplied by 26. So 65 times 26 is 1,690y. Good, those are exact opposites. Negative 33 times 26 is minus 858z. And negative 326 times 26 is negative 8,476. Again, very large numbers, but we're going to keep going and see what happens. I'm getting rid of the y's. They're opposite signs this time, so I'm going to add these two equations together. Doing so eliminates the y, and I'm going to have 1625 plus a negative 858 is 767 z equals 10,010 plus a negative 8,476 is 1,534. And this is when I hope, when I divide by this 767, that I get a nice integer as an answer. All right, here we go. 1,534 divided by 767. Whew, z equals 2. And since for all of our problems, x, y, and z are going to be integers, this is a really good sign for us. If I would have gotten something like, 2.549, that would have told me, ooh, maybe recheck my work. All right, so that's phase 2. Phase 3 is now we just start and we go back a step each time and plug stuff in. So if I know that z equals 2, then I can go back a step to, I got this from equations D and E, so I'm going to plug this into either equation D or equation E to find out what y is. So I'm going to pick equation E. Why not? So let's see, do I have room here? E is going to be 65y minus 33, but z is 2. So I'm just going to go ahead and plug in right away. Equals negative 326. So 65y minus 66 equals negative 326. We'll add 66 to both sides. $65y equals negative 326 plus 66 is negative 260. And then I'm going to divide both sides by 65. Dividing both sides by 65. I get, let's see, y equals negative 4. All right, and I got that by plugging in z into equations D or E. I chose E. And I got y equals negative 4. So now I'm going to go another step back to equations A, B, and C. I'm going to pick one of those and plug in z and y. So let's just do equation A. That's fine. Equation A is 3x minus 2 times negative 4 plus 7 times 2 equals 13. So then this is 3x plus 8 plus 14 equals 13. 3x plus 22 equals 13. Subtract 22 from both sides. X equals, let's see, that would be negative 9. And then finally, divide both sides by this 3. X equals negative 3.